Have you ever tried to speedrun an architecture diagram only to find out that there are way more options than you expected? This time on DevHack. Hello and welcome to DevHack. I'm your host Dade.
And I'm your co-host Adam.
And this is where developers and hackers come together to learn best practices and build better software. Before we dive in this week, we want to thank you all for the warm welcome and all the feedback that we got on our first episode. It means a lot to us that we watched, and we hope that you enjoy our future episodes as we dive deeper into the project.
In our last episode, we talked about some of the challenges that we faced with the initial version of Natlas and why it was a little bit hard to evolve it, as well as some of the alternative approaches that we're going to take for our new platform. So before we kind of get started doing some coding, first thing I'd like to do is just start working on an architecture diagram. And an architecture diagram just helps to set what are the different components that exist in the system, who's calling what, how are the different systems integrated and connecting to each other. And there's a number of different common styles of architectures that always give you a head start on building an architecture diagram. For example, you could be building some sort of bulk data processing system that processes large amounts of data. And it's all about throughput as opposed to latency. There's event processing systems where you want to respond to some event from another system in a low latency way. There's backend services, there's front ends, there's different two-tier orchestration systems, and there's a number of different common architecture patterns. But what do we know for sure about our new Natlas? We know that there's going to be some sort of UI with humans looking at it, interacting with scanned data, looking at the results to see what kind of hosts are on it. We know that there's going to be scan agents that are working to get new targets to scan and then going out and scanning them and then reporting the events back. So there's a common set of themes there that looks like it's got a front end, it's got some sort of standard two-tier architecture, and we'll kind of get into that, what it exactly looks like when we get to our diagram. But those common architecture diagrams strategies help us design the initial diagram. So let's kind of take a look at this architecture diagram here. So I've opened up diagrams.net, and it's a great way to help you flesh out some of the different diagrams and components and boxes. So, Dade, what are some of the people that are going to be interacting with this system?
Well, I think we're going to have kind of the end user who might be searching the data. We might also have like an administrator who has maybe higher level privileges to interact with the data, whether it's like maybe deleting bad data or changing the configuration of the running agents, whatever it is. I think those are kind of our two user scenarios.
Mm-hmm. So I'll kind of categorize that under like just a common humans, because admins versus viewers, more of a role concept than a separate entity.
Right.
We also have scan agents, right?
Yep, we have the agents that are doing all of the actual work, collecting all the data for us.
Mm-hmm. I always start with the end user, the customer in this case, and work inwards from that point, starting from left to right. So what else? We're probably going to have some sort of web app server that can respond to different requests from these humans. Probably will have some sort of database, right?
Yep, got to keep the data somewhere.
So we've got a web app, we've got a database. One of the things that we discussed in the previous one was that we wanted to be able to have separate API server that scan agents and humans can connect to, as opposed to having all of our API logic embedded in the web app, right? So we'll create one of those. And we obviously can't have our humans connecting directly to our web app and API servers because that doesn't allow us to scale out horizontally and add more instances as this application becomes more and more popular. So we'll create a load balancer here between those. So load balancer is just a way of distributing requests from scan agents and humans uniformly across the different servers in the backend.
So Adam, what if we wanted to serve our web app like right off of our API server? Why would we want to have like two boxes for this instead of just having it all in like the same application or the same like process?
That's a good question. And it really depends on scale and how many people are working on this project. There's a classic theory of microservices, and you break down larger monolithic components into smaller components. And one of the advantages is that you can develop them independently and you can have multiple teams. So, but it has the cost of more infrastructure that you have to set up, more code that you have to write as you split more things off into microservices, more things to monitor. So initially, I like to keep them as few components as possible, but make it so that I can split it out later. Make it easy to do that. So one of the ways that we can do that is, and let me make my lines a little bit clearer. If we run these together, like say that's part of the same application process, we can, our load balancer can route requests based on prefixes. For now, what we'll do is we'll just route everything to one process. But if we make the decision that all of our API requests are prefixed with API, even if they're in the same process, we can then later split them apart and move the code out and without any changes to the clients.
Okay. And then I guess like maybe a good rationale for that is like the API server is going to be handling a lot of requests from like the scan agents or from other like automated systems that maybe the web app doesn't, we don't need to be loading HTML and JavaScript when some other service is just consuming our API. So maybe we need to scale up the API server more than we need to scale up like the web app or something.
Right. Another reason to split out components is exactly that, scale. If two subparts kind of scale differently and that your API requests are larger, more expensive, or more common than another one, you want to be able to scale it out.
I see.
But our application is just getting started. We don't have Facebook, Google, Amazon level scale of requests. That's something that we can kind of defer as long as we decide to make as long as we leverage two-way doors versus one-way doors here.
I'm not familiar with the terminology. What is a one-way door versus a two-way door? Like I can go in and out of my office door right now. What's the difference?
So one-way doors and two-way doors are a very common problem in strategy for reasoning about architecture decisions at my company. And it basically describes a one-way door is a door that is a decision that you make in architecture that is hard to go back from, versus a two-way door is a decision that is easier to go back through. And software engineering, any decision can be fixed, any problem can be fixed with enough engineering resources, but that's a bad business decision to invest huge amounts of resources to fix something. So one-way doors versus two-way doors are all about how easy is it to, if you realize that you made the wrong decision, how easy is it to correct that decision? For example, like if you go down the path of highly coupling a bunch of components together, that might be a one-way door because it's later hard to fix it. If you define an API that you expose to all of your customers and you say, this is your inputs, this is your outputs, it's very hard to change that.
I see. So kind of like we just built one very large one-way door in the previous version of Natlas, and everything was very difficult to go back from. So let's maybe not do it that way this time. And it sounds a lot like it has kind of a similar notion of like related to like technical debt, where like maybe a one-way door is something that like once that's put in place, that's kind of large amount of technical debt if you ever have to change it.
Mhm.
Cool.
Not all technical debt is a one-way door, though. There's technical debt that can be fixed, and you're just deciding to incur that for now. But
Right.
a one-way door is definitely a technical debt because it is hard to fix it.
Gotcha. Cool. Cool. Yeah, I guess one other question about this like web app versus the API server. You know, I- I've seen a lot of people are really big into things like React and Vue, and um, I don't know if Angular is still big, but I know that that was at one point. Um, and that kind of brings us to like the idea of like a single page application versus kind of the more traditionally server side rendered applications. Uh, what do you think is kind of the right approach for building out our scalable system here, and maybe what are the benefits of whatever approach you want to take?
Mhm. So this is a long conversation in its own right, like single page for applications versus other things, and it's not always as easy as single page application versus server side rendering because those are actually can be two independent decisions. A single page application generally refers to something where you just have all the JavaScript, CSS, etc. loaded on the browser, and you can navigate to other pages without actually like a logical transition in the browser.
Mm.
But server-side rendering can be combined with single-page applications because you can initially render a web page when the client first requests things. So this has the advantage that it reduces first page load latency, and performance is something that's very important to me. I hate when web pages take seconds to load and tons of work
Yeah,
that happens.
the worst.
So you can combine those two things, single page application with server side rendering, and ship it to the client. Server side rendering is also good if you have um, constrained end devices because they don't have a lot of processing power for a service like a single page application. Also, like search engines historically have needed server side rendering. Some of the modern Google crawlers can handle single page applications, but it was generally in the past recommended to do that.
Yeah, yeah. Actually, that kind of is an interesting point as well. Even with like Natlas, we were doing a lot of screenshotting, and anytime we were doing screenshotting of something that was a single page application, it was usually just a white page because nothing was like rendering the JavaScript. Not like React has like the whole virtual DOM, and the like none of the actual DOM represented anything that was supposed to be on the page because I was just taking a headless screenshot of it basically. Um, cool. That was, I think, really an interesting approach. It sounds like maybe like a blend of the two is a happy medium.
Mm-hmm. Yes, and progressive enhancement is a terminology for this, where uh, you make your website work as much as possible with as minimal features on the client side as possible. Like, can it work without JavaScript? Depending on how Natlas develops, that might be hard, but
Mhm.
in countries in regions that have poor internet connectivity, like cell phones, if you're trying to load this on your phone and if you have to load multiple megabytes of data to load your single page application, you're not going to have a fun time. And
Yeah.
that's why you can combine these different technologies and choices to make a good solution for everybody.
Cool. Yeah. And also, I mean, I know that a lot of Hack 5 viewers are the type of people who maybe don't want to run arbitrary large JavaScript applications in the browser and maybe prefer kind of a uh, lighter page load and less arbitrary code running. So I think that's a good thing. Let's maybe jump back to the diagram now.
Mm-hmm. So it's easy. So what we'll do is all of our clients, like our humans, will always connect through our load balancer before going to the web app, just to enable us for scale. And then we have our decision for the scan agents. We could have scan agents because we made the decision that scan agents are going to be trusted and always run and hosted by the same person that's hosting the backend, you could have the scan agents connect directly into different queues, databases, and internally do things. So that is easy, and that is easy to get that written and going. But some of the challenges is that now your scan agent is highly coupled to the backend architecture, the backend components, and that can have security ramifications. That can also just make it harder to evolve the backend.
Yeah. I guess like one thing I hadn't even really considered kind of the security components of it, but if you wanted your scan agents to be able to just put data in the database, that means all your scan agents have to have the database credentials that have write access to, the table. That's not something that I would be very comfortable with, doing it that way.
Right. So after an architecture diagram, commonly people will do some sort of security diagram to then say what are the different domains. So we'll get to that actually in a little bit. But I always like to have scan agents go through our API too, because it allows us to expose a couple APIs, and that's the abstraction that the agents can work with.
Yeah. In the previous version of Natlas, agents mostly they would get work from the server and then they would submit work to the server, and then there were a couple of kind of supporting APIs for things like getting the list of ports to scan, or uh, getting like scan configuration, stuff like that. But it was definitely kind of a afterthought in terms of being a structured API. So I think planning for that in advance is a nice approach that we can take.
So let's think about other parts of this diagram that we're looking for here. We have our web app, and it's very common for any sort of static assets to, like JavaScript and CSS, to serve those out of a CDN or something outside of the web application, so that the web application is just focused on our raw, like authentication, authorization choices, things like that. So
Yeah, so maybe something like a I don't know what all the different CDN options are. I know like CloudFront is one CDN. I think like maybe Cloudflare has a CDN product. So wherever we end up building, having something that we can like shove our JavaScript and our CSS and maybe like the logo and stuff like that into, right?
right, because all of that stuff can be served agnostic of this web app. It's all very static. It's all very cacheable.
One interesting thing about like kind of the design that you've just gone with is that now like the end user is reaching the CDN assets directly. Is there a benefit to having that versus having it like behind the load balancer, and then it would be on maybe like the same domain, right? If it's behind the load balancer, then everything is natlas.io, and you have like the API routes that go to the server. You could have like static routes go to the CDN. Is there a problem with doing it that way, or is this like the better approach to go with?
So it really depends on what this load balancer is. If my expertise is in AWS, and a load balancer will run in a single region, like an ALB will be in a single region, which means that if an end user is connecting to static assets, they have to go to that one region. And a load balancer, like a CDN like CloudFront or Cloudflare, they run in multiple regions and in multiple different data centers all around the world. So technically, this diagram is kind of eliding the fact that there is a load balancer in front of these static assets.
Okay.
And it's kind of embedded in the CDN this box here. However, if we do not introduce a full-blown CDN like CloudFront, Cloudflare, or etc., then it would be very common to have a prefix for static assets.
Right.
That goes
like /static, and then you'd serve those out of like a S3 bucket or something. Something that can be cacheable, and like your web server or your web application doesn't have to handle those requests.
Right. So I think for the time being, for us to get started here, because again, we're not really going large scale, I think your prefix idea would actually be a good one right now. And we'll change that.
Cool. Yeah, because I think like the one thing, if you had the users connecting directly for the static assets to the CDN, then you would need like another domain that those assets are loaded from, because they wouldn't be able to just be loaded from like the root natlas.io. You need some way to indicate, hey, go to the CDN. So you would need like static.natlas.io or cdn.natlas.io or something like that, right?
Again, it depends on which CDN you're using.
It always depends.
Right. Everything depends. If you are using something like Cloudfront or Cloudflare, your CDN could be serving up natlas.io, and you could be routing /API star to the API server /assets to this area.
Okay.
So your CDN could become your front load balancer.
Gotcha. Cool. Yeah, I didn't know you could do that. That's neat.
Mm-hmm.
Cool. So we've got our API stuff going to our API server. We've got our assets going to some CDN of sorts, and then we've got our web app. Anything that's not assets or API going to the web application.
So let's talk about storage. So we will need to spend some time thinking about what storage technologies that we will use. For now, I'm just going to use some sort of placeholder database, because there's a number of different technologies we can use in the back end. There's RDBMSs, there's key value stores, there's things like Elasticsearch, tons of different technologies. I think we have an entire episode for that.
Yeah, definitely. That's a upcoming episode 4 or 5 probably.
Mm-hmm.
But for now, we know we need to store data somewhere. So that's what we know right now.
Mm-hmm. And I'll drag both of them here.
Does the web app? I guess how does the web app query the database? Is it just? I guess I don't follow why the web app's talking directly to the database instead of like getting it from the API server.
So what should the web app be responsible for then?
I guess the way that I was seeing it is like the web app just loads it from loads data calling kind of this like internal set of APIs /APIs/star, internal APIs, and like the API server is responsible for like knowing what the data models are and therefore knowing what like how to interact with the database.
Maybe. So if you have things like user identities, because you're doing authentication authorization, those belong in the database.
Mm-hmm.
We could route everything through the API server, but I think we need to kind of decide what is the roles and responsibilities of this API server. Is it purely for like a proxy to the database, or should it be an API server for specific categories of operations, like working with scan data, working with anything else?
Right, kind of like the internal API versus the external API kind of perspective. The internal API is all the things that the web app are just calling to do things like log in or reset a password. I think especially common in like the single page world is like the concept of the internal API. Cool. I mean, I think like it makes sense right now. I just I wasn't sure if I understood how the web app also talks to the database.
Mm-hmm. If you decide to go with the proxy to the database approach, and architectures kind of evolve over time, so this might change. But if you decide to do that, now you have to have APIs for everything, and the cost of building an API that is exposed externally through like this is going to be higher, because you're going to want to spend more time making sure that your requests are valid or make sense, your response make more sense. And I prefer, at least when I'm initially starting a project, try to keep as many APIs as internal as possible.
Okay. Yeah, I think that makes sense. I guess like what other kinds of parts of our architecture we have? I think we're starting to run a little late here, and so we'll want to get the rest of it so that we feel comfortable with like this is the architecture for our project. We like honestly, I think this accounts for most of it, right? We have a database that we store our data in. We have our web app and our API server that like actually handle our requests. We have a load balancer and static assets, and we have like our scan agents listed. I guess like maybe one other thing is say we're going to use Nmap because that's what Natlas is used up until this point to do our scanning. Nmap produces output files in like XML or .nmap or .gnmap. Previously, we just shoved that all of those data formats straight into Elasticsearch as like data fields on the data model. Do we want to just shove them into Postgres? Like if that seems like maybe that's not a good idea. Is there like a better option for where we should store them?
Mm-hmm. So a full-blown architecture diagram takes much longer than 20 minutes to come together. So we're making a couple liberties here, and we will evolve this diagram as we develop this project and this series out. I'm sure there will be some changes that we'll make here. But I think you're asking, is there a difference between some of this index data versus raw data? And yes. So if you have the raw data from Nmap in that raw XML format, you could immediately transform it to our indexed, our domain model that we're going to store in the database that's going to be used for serving up all of the web pages and indexes. But then if you ever change things, if you ever want to add more data or add a new column, it's sometimes useful to have our raw data available from all the scans. And that allows you to do things like redrives, where you have the output from Nmap, and then you can write a process to re-import that into the database if your database schema ever changes. And that simplifies things.
I see. So we can have like a simpler architecture or a simpler schema of like we're just indexing like the ports that are open on a given host, and maybe also like the service that's running on that, and like certain structured data, but maybe we are not storing like complete SSL certificates, even though that might be available in the Nmap output. And then, yeah, I like that. Like the what did you call it? Redrive?
Yes, redrive is the term I always use for this.
Okay.
This is an example of a two-way door. If you shove all that raw data to a store, you can later extend and extract more information from that raw data. So let's add another box here, and we'll kind of explore that a little bit more. Raw scan. So a common thing to do with raw data, bulk data that you're not going to like query against, is to store in like a bulk format that's not indexed. And the common strategy today is some sort of object store. And this includes things like Google Cloud Storage or S3 or any other object store in which you just have your key as the name of the object and the value is a large chunk. None of the contents is indexed, but for now I think that'll work for us.
Cool. Yeah, I mean that seems, because then I guess like the database, if we have like a record that represents a particular scan, then we can just store like the object key next to like the scan data in the database. That way, if we ever need to like repopulate or like reprocess a particular scan, we know how those two kind of line up together without having to store all of the data in the same place. I think that's way better than what we were doing before. I think with that, like, do you feel like this is a good architecture to get started on?
I think it's ready for the next phase of the project.
That's
no architecture diagram is ever perfect.
Fair. I think it's ready for the next phase. That's a good way to describe it. This has been a really informative episode. I think we got to go in and do our architecture together. Maybe want to ask, have you, to the users at home, have you ever had to come up with like kind of difficult trade-offs when you were deciding how to build a project? Or maybe have you ever built a whole thing before you did your architecture diagram and then really wished that you had an architecture diagram to base it off of? We want to hear about the things that you've done. So feel free to leave that in the comments below.
As always, you can follow along with our progress on GitHub, test it out, fork it, fix it, make feature requests, or whatever else you want to do to show your interest.
You can also submit questions, comments, feedback down below in the comments section. Or if you prefer to send us an email, you can reach us at devhack@hack5.org.
If you made it this far and you like what we're doing, be sure to leave a like and subscribe to see what we do next time. If you really like what we're doing, you can toss a couple bucks our way on Patreon, but don't feel like you have to. We're just doing this for fun.
I've been Dade.
And I'm Adam.
And we put the over into overengineering.
Thanks for supporting Hack5. Find all our shows, community, and Pentest products at hack5.org.